We're going to focus on complex and irrational roots. There are some rules that are really important. You must know that complex and irrational roots always come in pairs. So that means that if we have a root, we're told that 2i is a root, then that means that negative 2i also has to be a root. If we're told that 1 plus root 3 is a root, then we also know that 1 minus root 3 is a root. So just be careful. You may not be given both roots of the pair. You might only be given one. And if you are, you must assume that the other one is a valid root as well. So let's look at the example below. Write a polynomial of least degree with real coefficients in standard form that have zeros of x equals 5 and x equals root 3. So even though the question is not telling us that there is a pair to root 3, we must just insert that because we know that that irrational root has to come in a pair. So step 1 is identifying any missing roots. So now that we have identified our missing root, which is negative root 3, we are going to do step 2, where we're going to create the factors. So I'm going to write f of x is equal to x minus 5, x minus root 3, and x plus root 3. So we have created factored form of a polynomial. Now that we have factored form, we're going to expand and go into standard form. So I get x times x, which is x squared. Outer is positive root 3x. Inner is negative root 3x. And last, we're multiplying a negative and a positive, so that gives us a negative. And then root 3 times root 3 is going to give us negative 3. Now I'm going to simplify. So I still have that x minus 5 out front. X squared minus 3. And then I still have to continue to expand into standard form. So we get x cubed minus 3x minus 5x squared plus 15. And the last thing is I need to put this in standard form. So x cubed minus 5x squared minus 3x plus 15. So I wrote the next couple steps. Step 3, expand. Step 4, make sure that we write it in standard form, meaning that we have descending exponents.